Somewhere in the early universe, there is a galaxy that should not exist. Not because it is too far away, not because it is too faint, but because it is far too big and far too old for the universe it was born into. In 2023, a team of astronomers pointed the James Webb Space Telescope into the deepest darkness we have ever photographed. What came back broke the models scientists had trusted for decades. This is the story of the galaxies that shouldn't be there, and what they might mean for everything we thought we knew about the birth of the cosmos. To understand why this discovery matters, you have to understand what Webb was built to see. Launched in December 2021, the James Webb Space Telescope is the most powerful infrared observatory ever built. Unlike Hubble, which sees mostly invisible light, Webb is tuned to infrared, the wavelength that ancient, distant light stretches into as it crosses the universe. The further away something is, the further back in time we are seeing it. And Webb was designed to look back further than any instrument in history, toward the first few 100 million years after the Big Bang. Astronomers call this era cosmic dawn, when the first stars and galaxies switched on and began lighting up the darkness. According to the standard model of cosmology, galaxies at this stage should be small. They should be young, faint, just beginning to form, built from a handful of newborn stars. That is what decades of theory predicted. That is what simulation showed. But when Webb's first deep images were analyzed, something did not add up. In February 2023, a research team led by astronomer Ivo Labbé published findings describing several galaxy candidates from roughly 500 to 700 million years after the Big Bang. These galaxies appeared to already contain many billions of times the mass of our Sun in stars. That is comparable to the mass of the Milky Way, a galaxy that took over 13 billion years to build. These candidates appear to have done it in a fraction of that time. The press nicknamed them universe breakers, because if confirmed, they didn't just bend the rules of galaxy formation, they shattered them. To understand why this is so strange, think about how galaxies are believed to grow. In the standard picture, small clumps of gas collapse first, forming small clusters of stars. Over billions of years, these clusters merge, gas keeps falling in, and slowly, galaxies grow larger. It is a gradual process, one that should take a long time to produce something as massive as the Milky Way. But Webb appeared to be looking at galaxies that skipped the line. Fully formed, star-rich, massive. In cosmic terms, practically instantaneous. Naturally, scientists did not immediately declare the models broken. Extraordinary claims require extraordinary scrutiny, and that scrutiny came fast. Some researchers pointed out a possible explanation: active galactic nuclei. These are galaxies where a supermassive black hole at the center is furiously feeding, glowing so brightly it can mimic the light of billions of stars. If some of these candidates are actually black hole powered rather than star powered, their true stellar mass could be far lower than first estimated. Follow-up observations and spectroscopy, breaking the light into its individual wavelengths, have since confirmed that at least some of these objects are real, distant, and still surprisingly massive. Even after accounting for black hole contamination, a genuine tension remains between what Webb sees and what our models predicted. Some of these early galaxies really do appear too massive, too quickly for the universe's age at that time. This isn't the first time Webb has found something like this. Other deep surveys, including Sea-Ears and Jades, have turned up dozens of unexpectedly bright, unexpectedly structured galaxies from the universe's first billion years. Some show hints of spiral-like structure far earlier than theory expected. Others contain supermassive black holes that appear to have grown far faster than current models can explain. Piece by piece, a picture is forming, one where the early universe was not the slow, quiet nursery scientists once imagined. It may have been far more chaotic, far more productive, far faster at building structure than anyone predicted.
So what does this mean for cosmology? It doesn't mean the Big Bang is wrong. The overall framework of the universe's expansion remains extremely well supported by other evidence. What it may mean is that our understanding of exactly how fast matter collapsed into stars and galaxies in the earliest chapter of cosmic history needs revision. Perhaps early gas clouds collapsed more efficiently than we thought. Perhaps star formation in the infant universe was far more intense, in short, explosive bursts, rather than a slow buildup. Or perhaps there are entirely new physical processes at play, ones we have not yet identified. This is what makes the discovery so exciting to scientists, even as it complicates their models. It is not a crisis, it is a clue. And clues are how science moves forward. Webb was built, in part, specifically to test the story of how the first galaxies formed. Nobody expected it to find galaxies that seemed to defy that story within the first year of full operation. Researchers are now racing to gather more spectroscopic data to confirm distances, masses, and stellar populations with greater precision. Each confirmed impossible galaxy adds more weight to the idea that something in our timeline of cosmic history is incomplete. We are, quite literally, watching scientists rewrite the opening chapter of the universe in real time. It is worth remembering what we are actually looking at when we see this light. The photons captured by Webb's mirrors left these galaxies over 13 billion years ago. They have been traveling, uninterrupted, through the expanding universe ever since. When Webb finally captures them, we are not just seeing a distant galaxy. We are seeing a fossil, a frozen snapshot of the universe when it was less than 5% of its current age. And in that fossil record, we may be looking at the earliest evidence that the universe built itself faster and more violently than we ever imagined. There is something humbling about that thought. Every model we build about the cosmos is our best attempt to explain what we can see, not a fixed truth carved into the universe itself. And every so often, the universe reminds us how much we still don't understand. The James Webb Space Telescope was supposed to confirm our picture of the early cosmos. Instead, it may end up rewriting it. So the next time you look up at the night sky, remember this. Somewhere out there, hidden in Webb's infrared images, are galaxies that grew up too fast for the universe they were born into. And unraveling how that happened may reshape our understanding of how everything, including us,